Hey class, so a few people have asked for a couple pointers on problem number 14 SN, where I'm asking you to actually enter an equation rather than just numbers. And so it's asking you to determine what the charge on capacitor 1 is here and capacitor 2 is here, given the fact that each of the 5 capacitors all have the same capacitance. We'll give the variable C2 and C4. Give the variable C to all of them, no numbers involved, and the voltage across it will be V. Okay? I decided to go ahead and number my other capacitors just to make things clear, so I'll call this one 3, this one 4, and this one 5. And what we can see is numbers 2 and 3 are in parallel, and those, or excuse me, numbers 2 and 3 are in series, and those together are in parallel with number 4. That group, C2, 3, 4, is then in series with 5, and then that group of all 2 through 5 is then in parallel with capacitor number 1. Okay? So, what I want to do is I want to look at the capacitance of each of these and try to develop some sort of an equation that I can enter into that little box for what Q1 is and what Q2 is. So first of all, I'm going to combine my capacitors to make the image a little easier to see what's going on. And there's multiple ways you can approach this problem, but I'm just going to kind of walk through a few things. So first I want to find what C23 is for the combined capacitors 2 and 3 in parallel. They both have a capacitance of C, so that's going to be equal to 1 over C23 will be equal to 1 over C plus 1 over C, which should come out to be equal to, that will come out to be equal to 2 over C. Therefore, C23 would be found to be C over 2. And then we can observe that C234 would be equal to C23, which is C over 2, plus C4, which is just C. And it can be observed then that C234 would be equal to 3/2 C. And then if we wanted to combine all 4 of those together, we would observe that 1 over C2, 3, 4, 5 is equal to 1 over C23, which is 2 over 3C, plus 1 over C for the 5th capacitor. And so that would come out to be equal to 5 over 3C. And so C2, 3, 4, 5 is equal to 3C over 5. Alright, so we could then draw this reduced circuit to look like this. Here's our battery. We have this capacitor here, another capacitor here, and that's all, right? It's our battery. And so this here is C2, 3, 4, 5, and this is C1. So it can be observed that both C2, 3, 4, 5 and C1 have the same voltage V across them. So when you're asked to find Q1, well, that's just going to be equal to C1 multiplied by the velocity across it, V1, and we can observe that C1 is a capacitance of C, the voltage across it is the entire V, and so you would just enter into that box CV. C times V is what Q1 is. Alright? Q2 is not going to be quite so simple, but again, when you get a solution, you're going to enter something. Say you found that it came out to be equal to 3/5 C times V, you would enter 3 over 5 times C times V. So that's the format that you're looking at, but that is not the answer, just so you know. To find the answer, what you're going to have to do is look at charge and voltage on these different sections of the capacitors 2, 3, 4, and 5. So for example, the charge, let's say Q2, 3, 4, 5, that would be equal to the capacitance, 3/5 C, multiplied by the voltage, which is the entire V, across that whole unit. Okay, so this whole unit, dealt with as one capacitor, has a total charge of 3, 4, 5. Or 3, for 2, 3, 4, and 5 has a total charge of 3/5 C times V. So if we look back up here at our original circuit, we can observe that capacitor 5 is in series with 3, 2, and 4. And so we know, since they're in series, they're going to both have the same charge. So we could observe that Q234 would also be equal to 3/5 CV, and Q5 would have that same value of 3/5 CV. Okay? Now say we wanted to, for example, find the charge, if we wanted to find the voltage across 2 and 3 to try to find what's going on with 2, if we want the voltage just on this side, well, we know that's going to be the same as the voltage on this side, right? So the question is, how much voltage is coming to this portion of our circuit? Well, we don't know for sure, but we do know that the overall voltage, I'm going to scroll up to make a little room, we do know the overall voltage on that side, as we discovered earlier, V5 plus the V for 2, 3, and 4 equals 1 full V, right? Because that's the voltage that we saw here for the whole thing, and since they're in series, they add. So that we could find what is the V just on capacitor 5. Well, we know that Q5 is 3/5 CV, and we know that Q equals CV, so C5 is C, and V5 is what we're trying to find. You cancel out the 5s, and so the voltage across just capacitor 5 is 3/5 of the overall voltage of the battery. What does that mean about V234? Well, that's V minus 3/5 V, because that's what goes here, and you'd find that that's 2/5 times the overall voltage. Okay? So I'm going to stop here and let you guys try to work at the rest. You can continue the same process to find what the charge is just on capacitor 2, and then again you're going to enter it in a form similar to what you see here and what you see here. So I hope that helps. Let me know if you have other questions. I'll be in my office during office hours tomorrow as well, so feel free to stop by. Have a box-worthy evening.